So the next one is LCD. So having read about LED, the other common display unit is a LCD. LCD stands for liquid crystal display. So same like LED, you will have LCD is also a medium used for display of numeric and alphanumeric characters. In either you can have a 7-segment display type LCD, or you can have a dot matrix type LCD. As we have seen, the same type of 7-segment and dot matrix type for display LED structures were there. The same can be incorporated for LCDs also. But LCDs don't work on the basis of junction diodes or recombination, nothing like that. They are going to use liquid crystals inside them. So the two commonly used liquid crystal materials which are used in LCD are nematic and cholestric. So the two types of liquid crystals are used. One is nematic, another one is cholestric. So they have shown this in figure 5.27a. So see here, this is the structure of a nematic and cholestric crystals. Okay. So this one, first one is going to be the nematic crystals, and second one is going to be the cholestric crystals. And this is the construction of the dynamic scattering LCD. We will see for the theory and comes. The most popular type is nematic liquid crystal NLC. And in this type, all the molecules align themselves to a parallel axis when retaining the complete translation freedom. So these LEDs are very, very sensitive devices. And you see, if I'm going to apply an electric field in this direction as given by the arrow mark here, all the molecules you see here, they will be aligned along the direction of the electric field. And if I remove this field, they will randomly align themselves. So this LCDs, if I'm going to apply an external field, these nematic crystal molecules will align themselves along the direction of the field, as long as the field is there. But see here in cholestric crystals, you have a separate structure. You have several layers of helical axis and director. But in nematic crystal, the nematic structure is very, very simple to fabricate and understand. So this is the commonly used liquid crystal display available in the market. So as and when an electric field is applied, all the nematic crystals are going to align themselves along the direction of the electric field. Okay, so that is what is given here. And the liquid is normally transparent. If subjected to electric field, the liquid crystals may polarize and turn opaque. Polarize means aligning themselves along a particular direction. So normally they are transparent, but if you are going to apply electric field, they will align themselves in a particular direction and they will turn opaque. They will not be transparent. They will become opaque. So the removal of electric field will allow the crystals to regain their original form and they become transparent. So as the simple logic, as long as the electric field is there, they will be aligned along the field and they are opaque. But if you remove the electric field, they will return to its original form and orientation and they become transparent. So based on this property of liquid crystal display, they are classified into two more types called as dynamic scattering type and field effect type. So they are classified into dynamic scattering and field effect type. So in dynamic scattering type, the construction is shown there. I'll show you. So you have two glass plates, each coated with tin oxide on the inside with transparent electrodes separated by liquid crystal layer 5 to 50 mm thick. So see here, you have two electrodes which are transparent. They are made up of tin oxide on the inside with transparent electrodes separated by a liquid crystal layer. So you have two glass plates. See here, this is one glass plate and this is one glass plate. And I have the transparent electrode fitted on the inner side of both the glass plates and it is coated with tin oxide. And in between the two glass plates, I'm going to have a liquid crystal. On both sides of liquid crystal, I'll be having the spacer. Okay, that is what is given here. The oxide coating is etched to produce a single or multiple pattern of characters which each segment properly insulated from each other. So a weak electric field, if you apply a weak electric field to these liquid crystal, you know the crystal molecules will align themselves to the direction of the